Today, let's look at the second part of 6.1, solving equations by using inverse operations. We will focus on how to solve the linear equations with brackets today. So let's look at how we can solve the first example. Solve 2 brackets m plus 4, close the brackets equals 11. The first method is to use the inverse operations. If we want to use this method, let's try to build the equation following the BEDMAS. With the BEDMAS, we know if we have the brackets, we always do the operations in the brackets. In the brackets, it's m plus 4. Then I get m plus 4 first. With the entire brackets, then I multiply these brackets by 2. So I will get 2 times m plus 4. And right now, this left side is equal to the right side, 11. If I want to solve for the unknown m, I need to reverse the order as well as the operations. Multiply by 2, that's the second operation that we did when we build the equations. So when we solve for m, we need to reverse this operation first. So we divide 11 by 2. 11 divided by 2, that's 5.5. So this 5.5 is m plus 4. Look at the operation in this step in building equation. So this one is plus 4. Then we go backwards, we need to use the inverse operation, which is subtracting 4. So 5.5 subtract 4 is 1.5. This 1.5 is the unknown for m. Okay, if we want to write down this solution in the algebraic steps, so what we can do is, following the model, the green model here, so I will divide both sides by 2 without removing the brackets. So 2 divided by 2, 1. 1 times m plus 4 is the same as m plus 4. 11 divided by 2, 5.5. m plus 4 equals 5.5. We know how to solve this equation in the first part of 6.1 already. We isolate plus 4 from m. We subtract 4 from both sides. So m equals 5.5 minus 4. And these two got cancelled out. So it's 1.5. So this one is when we solve an equation with the brackets, we did not remove the brackets first. We divide both sides by the constant in front of the brackets. Then we solve the variable in the brackets. Let's look at the second method. The second method is, I want to remove the brackets first using the distributive property, then inverse the operations. We know the distributive property already, which is a times brackets b plus c. We can distribute this a into the brackets for each term. So we will get a times b plus a times c. In the second method, I will use the distributive property to remove the brackets first. 2 times m, 2 times 4. 2 times m is 2m. Plus 2 times 4 is 8, equals 11. Then you will see this equation is the ones like what we talked about in the first part of 6.1. Right now, we can use the inverse operations to solve for m. We need to isolate plus 8 from 2m first. So I subtract 8 from both sides. Positive 8 minus 8, they got cancelled. 2m equals 11 minus 8. This one is 3. Then I divide both sides by 2. So m equals 3 over 2, which is the same as 1.5. I'm not so sure which method you guys like the first. But right now, we have 3 questions. I want you guys to have a try to use the method you like the most to solve those equations. For me, I prefer to use the first method. instead of using the distributive property. But of course, if you like the distributive property, you can remove the brackets first and find the value for the unknown x and check the answer with mine. As long as you guys can get to the same answer as mine, that means your solution is correct. So for me, I will use the first method to solve both of these two equations here. I will divide both sides by 2 first, before I remove the brackets. So 2 divided by 2 is 1. Then 1 times brackets negative 3x plus 1.5. I just put a negative 3x plus 1.5 simply. 6 divided by 2, 3. Then I use the inverse operations to solve for x. I subtract 1.5 from both sides, and they got canceled out. So negative 3x equals 3 minus 1.5 is 1.5. Then I divide both sides by negative 3. Negative 3 divided by negative 3 is 1. So 1x equals 1.5 divided by negative 3, which is negative 0.5. The second one is, I will switch around these two sides of the equation first. I will put the variable y on the left side. Then I will divide both sides by negative 2 before I remove the brackets. So I divide both sides by negative 2. Negative 2 divided by negative 2 positive 1, you can omit this 1. So it's just negative 3 minus y equals 7.6 divided by negative 2. And this one is negative 3.8. Then I want to use the inverse operations to solve for y. In this equation, I need to isolate negative 3 from negative y. So I add 3 to both sides. And these two got cancelled out. Then I will have negative y equals negative 0.8. And you guys need to remember my goal is to solve for 1y. This one means it's positive 1y instead of negative 1y. So this negative y means negative 1y. What I can do in order to cancel this negative sign is to divide both sides by negative 1. Negative 1 divided by negative 1 is 1y equals negative 0.8 divided by negative 1 is 0.8. Okay, the last one, which is example 2, it's a problem solving question as well. I hope that you guys can have a try to set up an equation and solve the equation. Use one of these two methods we introduced in this lesson. A rectangle has length 3.7 centimeters and the perimeter 13.2 centimeters. Write an equation that could be used to determine the width of the rectangle. First, let the width be x. Or you can say the width be y. Or you can say the width be w. You can choose one variable to define the width. And we need to look for this width, which is x here. Based on the parameter, I know you guys probably will have different ways to set up the equation for the parameter. But for me, this is one way to set up the equation with the brackets. So I will say 2 times brackets, 1 length plus 1 width. That's 13.2. But some of you guys probably will set up an equation without any brackets. That's okay as well. They will do 2 times 3.7 because we have 2 lengths, then plus 2 widths equals 13.2. If you use the red equation, there's no brackets anymore. Okay, but no matter which equation you set up, you should get to the same width value. So if I want to solve the blue one, I would divide both sides by 2 first. Of course, you also can use the distributive property to remove the brackets first, then use the inverse operations to find the x value. So for me, I want to still follow the first method. 2 divided by 2 is 1, so it's only 3.7 plus x equals 13.2 divided by 2 is 6.6. 3.7 plus x is the same as x plus 3.7 equals 6.6. Then you will realize which number you need to isolate. So I need to subtract negative 3.7 from both sides in order to cancel plus 3.7. So then I will have x equals 6.6 minus 3.7 left, which is 2.9 centimeters. So this is the width value. Verify the equation, or we can say verify the solution. You can just by subbing 2.9 into the equation for x to look at if this parameter is 13.2. If 2 times the brackets 3.7 plus 2.9 equals 13.2, that means your 2.9 centimeters is a correct solution. Then draw a conclusion. The width of the rectangle is 2.9 centimeters.